Hi everybody, and welcome to this session on building .NET Core applications with Service Fabric. I'm Vaslav Turacek. I'm a program manager on the Service Fabric team here at Microsoft. So let's get started and we'll show you a couple cool things here. So in this session, we're going to go through two sections here. We're going to cover some basics, and this is just showing you everything you need to know about building .NET Core applications on Service Fabric. So we'll cover everything kind of from start to finish, going off of one of our sample applications. So we'll mainly cover how to do ASP.NET Core services. We're going to talk a little bit about using reliable collections from ASP.NET Core. And then we're going to spend quite a bit of time actually on service communication, how to get services to talk to each other, and also how to get services to communicate to the outside world, so ingress traffic coming in. And then we'll cover a little about developing and debugging with Visual Studio 2017 and the built-in Service Fabric tools that we have there. And so most of that's going to be pretty basic, but later I want to cover some more advanced topics, especially around partitioning and how to scale applications and data-driven applications on Service Fabric. So make sure you stick around for that. Some prerequisites here. So if you want to follow along, make sure you have your dev environment set up for Service Fabric using Visual Studio 2017. You can find that in our documentation here under the Getting Started section. And then we have the sample project. So we're basically going to be building this sample project from start to finish and then extending it afterwards to add a little more functionality, which would be pretty cool. So if you want to pick that up and clone that to follow along, now's the time to do that. Okay, so let's go ahead and just dive right into the basic part of this. So like all good things, we start with Visual Studio 2017. Okay, so I got a blank Visual Studio, and so we're going to start by creating a Service Fabric application, something for you veterans that have probably already done this 1,000 times, but we'll just show you how this is done. So we go into Visual Studio and we have these templates for Service Fabric applications. Now you get this if you install the Service Fabric package along with the Azure tooling that comes in built in with Visual Studio 2017. You should see this pop up right away. And so we'll just go and create this application here. So this is our voting application that allows us to just kind of vote on a few things, save the votes in the back end, keep track of how many votes are coming in, and then just display a UI. That's kind of the gist of the application. Pretty simple. So we'll create that. Now in this next section here, this you might not see in your Visual Studio 2017 just yet. This is a package that we released fairly recently with a preview of our .NET Core 2.0 templates. So later on, if you're watching this later, you'll see this is probably already built into Visual Studio, but at this time, if you go onto our blog and download this, this set of tooling, you'll be able to see this there too. So we'll start with here. So we're going to start with creating a stateful ASP.NET Core service. And so actually we're going to go backwards by starting with the back end first, and then we'll come back and add the front end in a little bit later. So let's start here, and we'll create the service, and we'll call it voting data. All right. So creating this now, it's going to create a couple things. It'll start out by creating the Service Fabric part of the project, but then it's going to kick us over here to the ASP.NET Core web application. So this is all the templates that you normally see when you're creating ASP.NET Core. You've got your web API, MVC, and of course your React and Angular project. So since this is a back end and we don't have a UI, we're just going to pick web API and start with that. So this is going to create our Service Fabric application project, and then it's going to create the service project. Now the service project, let's go over this in detail. I want to actually dive into this a little bit just beyond the surface and show you what is happening in this project and how it actually hooks up ASP.NET Core with Service Fabric. So what it does, what Visual Studio tooling does here is it creates that ASP.NET Core application, and then it injects a few Service Fabric things to make it work on Service Fabric so you can run it there. So let's take a look at what that means exactly. By starting first with the project itself, if we look into here, if you look at the CS proj, we can take a look at what's in here. So this is just our usual, very simple, nice simplified .NET Core project style. And all it's doing is referencing a few packages. At this time, we have our preview packages here. So our version 3 preview, these are .NET Standard 2.0 Service Fabric NuGet packages. So by building against .NET Standard 2.0, it allows you to build your applications against either .NET Core 2.0 or full .NET Framework 4.6.1 if you want. You can see up here we're targeting .NET Core App 2.0. So that's really all that's in here. Now, the rest of this down here, this is your typical ASP.NET Core project stuff. So you got your www root, you got your controllers, and if we go down here, now this is where we start to see some of the Service Fabric project items. So let's start with the project up here. If we go into the properties, you can see that this is actually just a regular old console application, and this is an important thing. So when we get into the entry point of that. So we go down to the program and the program main. Here's the entry point into that console application. The important thing to notice here is that we're not actually doing any of the ASP.NET Core work just yet. So everything you see in this entry point is actually just bootstrapping the service and registering it with the service runtime, which is the service fabric portion of this. So what this means, when you do this registration of a service with the service fabric runtime, what you're saying is that this process that's going to run, this exe, you're saying this exe is allowed to run services of this service type here. So what that means is when you go later on to deploy this service into a service fabric cluster, Service Fabric will spin up this process, and this is what we call a host process. And this is part of the hosting and activation mechanism that we have in Service Fabric, where if you're using our reliable services APIs, we spin up a host process, and then inside that host process, we instantiate your service instances every time you create a new service. And so this part here is basically just saying these are the service types that are allowed to run in this process, and that's all this does right here. So if we move on then to here, now we have this Lambda method which says, okay, here's the Lambda method I want you to run whenever a service is created inside this host process. So this is kind of the opportunity you have to do dependency injection and plug whatever you need to into your service instance through this Lambda method down here. So if we go into here, now we are at our actual service class. So you can see our service class implements a stateful service. So now we're in the Service Fabric SDK, the Service Fabric APIs. So this is kind of the core of the service. This is your starting point, your entry point. It's very bare bones. You'll notice down here at this point, you don't really have much of a framework to work with. There is no pattern that's really imposed upon you. It's actually pretty wide open. And if you create a regular Service Fabric service without ASP.NET Core, usually what you'll see is this run async method created for you in the template. So the run async method is your primary entry point in the service. This is where we say, okay, go run your code now. And your code can be whatever you want. So here you can run anything you want at all until this cancellation token is signaled by the platform to tell you to stop. So your service spins up, and we tell you to stop whenever we need to move you for, say, for example, an upgrade or for balancing or something like that. Now the second entry point in your service is down here what we call communication listeners. And this is kind of a way for Service Fabric to help you set up endpoints for your service. So if you have external connections coming into your service, you're going to do that down here by creating these communication listeners. And so of course with Service Fabric in the SDK, we provide several communication listeners out of the box that you can use. And the one that we see here is the ASP.NET Core communication listener that uses the Kestrel web server. So you can, of course, you can open up an endpoint inside a run async if you want, because ultimately, as we saw earlier, this is really just a console application. It's just an exe that's running, and you can open up whatever sockets or ports that you want. But the reason that we do this pattern here is primarily because when this thing spins up and your endpoint opens up, you want to register that endpoint with the Service Fabric runtime so that it gets registered up into the service discovery mechanism. And that allows other services to find the endpoint that you've opened up on. So let's dive a little bit deeper into what this endpoint thing is, because this is actually fairly important. So when we create this listener here, we're basically bootstrapping ASP.NET Core at this point. So this is what you normally see out in the program main. We're now seeing it here. And the reason is because we're actually starting up the service first, hosting it in Service Fabric, and then spinning up ASP.NET Core afterwards. So this is really the bootstrapping part. And this allows the ASP.NET Core application to participate in the Service Fabric application lifecycle. So the service itself has a lifecycle where it opens and closes. And if it's a stateful service, like in this case, there's another kind of state machine that's mostly hidden from you, but it is going on behind the scenes where we have to take the service and change the way it functions. So when it's stateful, you have a concept of multiple replicas of the service. So there's always a primary replica, secondary replicas, and depending on which form it's in, it has to open and close and do this kind of stuff. So there's a state machine happening behind the scenes that you don't really see, but by plugging into this model here, that gets you plugged in the right way, and that way your application starts up at the right time. So once we get past this, now this is just code that you can edit. This is again a Lambda method. You can do whatever you want in here. And this will do your regular ASP.NET Core application bootstrapping with the startup and everything else. So once we get to this point, we're kind of out of the Service Fabric world, and we're now more into the ASP.NET Core world. And from here on out, you're really just writing ASP.NET Core applications. So let's go in and start writing this application. So we have a voting application, and we have a values controller here. So first thing I'm going to do actually is I'm going to go ahead and deploy this. I've got a local cluster up and running. So I'm going to deploy this to my local cluster first. And I'm going to show you why I'm going to do that. So I have a one node local cluster running here. So this is on my local box here. And I've got a one node cluster running because, yeah, so there's what we saw there. So here, if we go into properties on the application, I've got the application debug mode here set to refresh application. And that little pop-up window you saw is Visual Studio asking permission to be able to do this, and you'll see why in a little bit. So refresh application is a way for you to be able to do rapid development using Visual Studio, because we are deploying this application to a real live running Service Fabric cluster. But every time I make changes to my application, every time I make code changes or even JavaScript changes or CSS changes, I don't want to have to redeploy the entire thing to the cluster, because it's a little time consuming, because it's doing quite a bit of work to compile and package and then register and deploy it onto a real live running cluster. So that refresh mode is a little trick that Visual Studio does, where it kind of uses symbolic links from your application project root here to the deployed location on the cluster locally, so that I can make changes here, recompile my application, and immediately see those changes reflect in the live running application. So it saves quite a bit of time as you're developing. It kind of simulates what you're used to with regular ASP.NET Core applications, where you can just make changes, hit refresh in your browser, and then they show up right away. So as you're doing your initial development, this is the best way to go, because you're going to be able to do this much faster by using this refresh mode. Okay, so we've got the application deployed. Now remember, this is just a bare bones ASP.NET Core application. It doesn't really do anything yet, but we can drill down into it and see that it's already started up here. So this is the service that we've created, and if we drill down into here further, we have one partition in the service, and then this is our one primary replica of the service running. We only have one because we only have one node on this local cluster. But you can already see that we've opened up an endpoint. So we have an HTTP address for this service running up, and it's got a lot of stuff to it here, which we'll come back to later and explain that a little bit more. But if we take this, we can actually hit one of the endpoints. So this is just the default API values that we get, and we can see that we can already hit that controller that gets generated by default by the template. So that's cool. Let's go in and actually write something more significant than just values. So here's that default controller. So I'm going to take this and I'm going to change this to the, let's call it the votes data controller. And so what I'm going to do with this is I'm basically going to write a web API application that uses a reliable dictionary as a backing store to keep track of votes as they come in. So the first question is, how do we get reliable collections into this controller here? So the way we do that is actually fairly simple, and the template even sets it up for you. So the trick here is when we go back to this service class, so this is our stateful service class, in here we have access to all of those Service Fabric goodies, like the service context, which gives you information about the service that's currently running, and it gives you access to, most importantly, the state manager. And the state manager is the thing that manages all of your reliable collections and where you create dictionaries and queues and set up transactions and all that good stuff. So what we do is we use the built-in dependency injection system that comes with ASP.NET Core to plug these things into the ASP.NET application. And you can see here I've added the state manager and service context through this dependency injection mechanism. And this way, when I come back to my controller, it will automatically show up in the constructors. So if I create my constructor here and I say I want my iReliable state manager, like so, then the dependency injection will automatically pass this in. And so then I can just save this up here in a private member variable here, my state manager. And just like that, I've got access to all of the stateful goodness that comes with Service Fabric inside an ASP.NET Core controller. So now, for example, I can implement a put method here, and I can grab a reliable dictionary and start storing data in it. So we'll set this up with a route on this API for a name, which is basically the thing that gets voted on. So vote comes in for some name, and then in this method what we're going to do is we're going to store a vote count for that name. Fairly simple. So first thing I gotta do is I need to make this asynchronous, because all of the operations you do with reliable collections have to be asynchronous, and I'll tell you why in just a moment. So here we go. So the first thing we got to do is we got to grab a reliable dictionary. So we do an iReliable dictionary, and we'll do it of type string and int. So the dictionary, the string is the name that's coming in. This is the thing that's being voted on. The int is just the vote count. Fairly simple. And we'll call this the votes dictionary. Okay, and this is where we use the state manager, and we say getter add async, and then we go and we grab this dictionary out of there, like so. And we just say, all right, so which dictionary do you want? So you give it a name. You can call it the votes dictionary or something like that. It doesn't matter. And just like that, we've got ourselves a reliable collection. Now we can start putting things into it. And so the way we do that is we start out by creating a transaction. And this comes from the state manager. We say create transaction. So one of the questions that a lot of time comes up here is, why do you pass in the entire state manager into this controller and not just the dictionary that you're going to use? And one of the reasons is right here in front of you, because you need that state manager to create transactions in order to be able to use a dictionary. So you always have to have this thing around. Okay, so let's go in here and we'll start actually using this thing. So this is actually pretty simple. We just say await, and we take that dictionary, and what we're going to do is we're going to use this add or update method on the dictionary. So we pass in the transaction, we give it a key, which is going to be the thing that's being voted on. And now we have this add value, which is just the initial value. So if this key doesn't exist, what value do you want to add? We'll say 1, since it's the first vote. And then we have this update value, which is, do you want to take an existing value and update it? And we pass in a lambda method and say, what do you want to do with that old value? And so what we're going to do is we're just going to increment it like that. Now, a quick note here, if you are doing this incrementation inside this lambda method, make sure you don't do postfix increment, because this will go ahead and return the old value first and then increment it, and you'll never see the thing increment ever. So if you're going to use that shorthand notation, make sure you're doing prefix like this, or like me, just say +1. So that's it. Once we added the value to the dictionary, last thing we have to do is now commit the transaction. And we're done. That's it. And then we can return OK. Great. So what's happening here? Let's go through this. Starting with the state manager, getter add async. What this thing does, when you say getter add async, the state manager is going to first look to see, do I have a dictionary by this name created yet or not? And if I do, I just return it right away. So it's actually pretty fast if the dictionary is already being created. So one of the things that you might be worrying about is, well, I have to do this asynchronous operation every single time I do a put. There is a hit up front, but every subsequent operation will be pretty quick, because it's just grabbing the dictionary from cache and then returning it to you. The first time you create it, when it adds it, what this has to do is it has to go out to the secondary replica. So remember, reliable collections are always replicated across multiple replicas of your service, and they're replicated across multiple machines even. So it's actually doing a network operation. It's doing network I/O to go out to the secondary replicas to say, hey, there's this new dictionary, make a record of it on the secondary so we can start writing data to it. And then it also puts it down on disk locally so that there's a record of it on disk. So that's why this is an asynchronous operation. Now, there's a temptation, I think, to take this reliable dictionary here that's created by this and cache it somewhere up here in a private variable, or possibly in the service class up here to just keep a cache of it so that it's a little bit faster as an optimization. I recommend not doing that because of that state machine that I talked about earlier underneath the covers, where the service fabric service is kind of going through different change role operations. There are edge cases and corner cases where you might run into this dictionary if you try to cache it and create up front, where it doesn't exist yet because it hasn't gotten to that point in the state machine, and you run against these kind of race conditions. So it can be done, but it's a little bit tricky to do that. The state manager is specifically designed to work every single time. So every time you get a dictionary out of here, you'll always get it and you always know it's available. So make sure you're doing it this way. If you do a little bit of profiling later on and find that this becomes a bottleneck for you, I would say then maybe look into some caching. But up front, start with this to get the functionality down first. All right, and so once we got that, then we go down here, we just add the values to it. So when we add the value initially, This is going to replicate the value, but it's not going to save it down to disk yet. So on disk, there's a replicated log, a transactional log, that keeps track of all the transactions that you commit into the dictionary. That doesn't happen until we actually commit down here. And so these are all asynchronous operations too, because these also are going across the network to the other replicas. All right, so that's basically it. It's just as easy as that. Now, let's test this thing out. So if I just recompile here, all I have to do is recompile. I don't have to redeploy because of that refresh mode we saw earlier. Just by redeploying, or by recompiling rather, I should be able to go in here now and issue a put request. So if I open up Fiddler, for example, I can then send a put request to the same address. Now the trick though is that the address has actually changed because we did do a redeployment, so we get a new address with a new endpoint, new port, and a new path. So I'm going to grab this new guy here, and we'll go and do a compose here, and we'll do a put request to that and see if it worked. Okay, and our API was API votes data, and then we have to give it a value. We'll say cats. We'll vote for cats. We'll execute that. And hopefully we should get a 200 response. Okay, so we got it in there, but now we really want to make sure it's actually working. So let's go and debug. So I'm going to hit F5 on this guy, and this will then relaunch the application and attach a debugger to it, just as you would expect normally with the F5 functionality. So if we go back into the data controller here, I can put a breakpoint and hit that endpoint again once it comes back up, once it's ready to go. Here we go. And we'll go and run that. Execute, and hopefully we should have a breakpoint. And yes, the address has changed again. So this is one of the tricks you got to watch out for, is this address will change on you when you redeploy. So let's go do that again under API. There we go, and execute. Okay, so now we hit our breakpoint on that put method, and we can kind of step through and see that it's actually running. It's putting it in. Sorry, I hit a key. There we go. Okay. And then if we step through, it'll go through and should be okay, and we got our 200. Okay, perfect. So, fairly simple. Now let's move on, and we're gonna add the second web service, which is the actual front end to this data service. So I'm gonna switch over. I actually have that already set up here. So in order to get to this point, all we really need to do is go into services here. We can go add a new service, and then we select a stateless ASP.NET Core service, give it a name, go through the same process, except this time the template I chose is the MVC template because we do have a UI. And the reason I started with this thing already created is because I don't want to write JavaScript. That will take forever. So that's already done, but it's mainly empty at this point. So you can see I have a home controller which loads up our UI here. So this is just some basic HTML. It's a basic Angular app, Angular 1, I believe, not Angular 5 or whatever we're on these days. And then we have a controller here set up, which is the API controller. And this is an API controller on that front-end service, which if we look in the JavaScript application here, so this is our Angular app. The Angular app just makes HTTP requests off to this controller here. Now, it's making these HTTP requests from the browser to this front-end web service, not to the back-end service. And this is an important point that we'll touch on a little bit. So these things are not implemented right now. So what I'm going to do real quick is I'm going to go and deploy this off to Azure just to show you a few things about how this thing works. So we're going to go publish, and I got my Azure endpoint. So I got a cluster set up in Azure already, and it's just doing authentication for me, and then we'll go and publish. Now, so the publish takes a few seconds while it does a couple things, and I'm going to show you actually what Visual Studio is doing right now as it's doing this publish. So Visual Studio has a couple tricks to make publishing a little bit easier for you. But what it's actually doing underneath the covers is it's just running these Service Fabric commands that are part of the Service Fabric API. So the first thing it does is it connects off to the cluster. Now there's a bunch of parameters that come in here, like the connection endpoint, which is what you saw. That was my cluster on port 19,000. And then we have a bunch of credentials that come in, and Visual Studio automatically populates these things for my secure cluster. Now the second thing it does is it goes and it compiles the application and packages it all up. So let me show you what that application package looks like. And this is one of the things that Visual Studio does for you, which is really nice. If I go into here and I look at the package output, it's putting together this application package for me. So it's still building that. And so what that does is it goes through both of these services. So I have two services in here. It compiles these two services, and then it grabs everything in this package root. And the package root is a service fabric concept. And this is where you have the definition of the service. So there's a service manifest file. This tells me what the service, how the service runs. It gives me an entry point in here. It gives me the exe that I'm going to execute. And then it also registers that service type. And this is the same service type that we saw earlier in the program main where we did our registration. So if you see here, this is where we did that registration. This has to match what you see over here in the service manifest. So Visual Studio is taking these package roots, it's compiling it, and it's creating service packages that it can then compile together into a full application package. And the full application package ends up in here, where we have our application manifest, which defines what services are allowed to run inside of this application. And then within each package, you see now this is the compiled web app here inside the code package. We have all the binaries, and there's a lot of binaries because we're targeting Win7 x64. So, but this is my final exe down here. So this is everything that needs to be run. So it's all self-contained. Everything is compiled together, self-contained, put into this package, and then by running this command, Visual Studio copies that entire package up to the Service Fabric cluster. So it's going to copy it up to something that we call an image store in Service Fabric. An image store is just a location to store application packages for later use when we go into this registration phase. And this is really the important part. When we call register, this is a provisioning step. And when this gets called, it takes that application package and gives it to the Service Fabric cluster and effectively says, here, you have this application now. Here's the application type and the version that I want you to know about. And from there, once that's registered, now we can create instances of the application and then run it. And so that's what's happening here. Now what Visual Studio does is really cool. It gives you these profiles, these published profiles, and these things, you notice, these don't show up in those PowerShell commands. These are actually constructs entirely out of Visual Studio, and it's just giving you a way to create profiles for different deployment areas. So if I want to deploy to different clusters or different environments, or even locally, I can declaratively set up these profiles, and Visual Studio gives you these parameters. So these application parameters that you see here in this XML, these flow down into the application instance that gets created, and then you can use these to parameterize the application for different environments. Now what Visual Studio is doing with this XML file is it's just taking this and feeding it into this new Service Fabric application command. You can see it down here under application parameters. It'll plug it into here, and that's all it does, because this is actually part of the Service Fabric deployment APIs. So that information just ends up in here, and then it ends up in your application. So that's what Visual Studio does behind the scenes when you hit that deploy button or when you hit F5 to go and deploy something. All right, so it looks like deployment's finished, so let's go check it out. So here we are in a Service Fabric cluster on Azure, and here's my one application that I've got deployed, and I have my two services. So if I go into the voting service here, the web service, you can see this is stateless, and it's gone and created an instance on every single node in the cluster. And this means that I have a separate IP address for each one, and they're all listening on port 80. And if we go into look into the backend application, I actually have two partitions here, and so now this is the important difference. If you look at the address here, it's very simple and it's on a well-known port. If I look at the address here on the stateful service, it is using a dynamic port and this long URL thing here. So the point here is if I want to go and connect to this thing, I can connect to that front-end application by just using the domain that I set up here, like so. And so this is just going over port 80, and this should load up that web UI that we created. So here's the UI that we created. So that works just fine. But if I want to hit the backend service, I don't really have a good way to do this. And so what I'm going to do is I'm going to switch over to my slides here because it's actually a little bit easier to explain with a few diagrams. So let's go back into here, and let's explain how this works. So service communication is what we're talking about here. So everything in Service Fabric, all communication in Service Fabric is based on this idea of service registration and lookup. So that communication listener concept that we saw earlier, where we create a communication listener and I said the address ends up getting back to the Service Fabric platform for service discovery later on, that's what this is right here. Any service, any client that wants to connect to a service has to go to these, what we call the naming service, which is our service discovery mechanism, ask for the address that was registered, gets the address back, and then it can go and make a request directly to that service. So everything in Service Fabric is based on this pattern, so keep that in mind. Now, when we created that stateful service, here's what's happening. So the stateful service is not going to be identical on every node. As we saw, we have a primary and we have secondary replicas of it, and it's usually only the primary that you're ever connecting to. So the primary replica can kind of float around. It's not available on every node. It can be moved around to different nodes based on failover or upgrades or whatever. So you always have to figure out, first of all, what is the IP address that this primary is running on. And then the port usually isn't static either for stateful services. You're usually getting a dynamic port. And so you don't know the port and you don't know the path. So this discovery thing is actually pretty important. So the client usually doesn't know up front what the address is. And of course, as we saw, the connection can fail at any point, which means the primary fails over, and now we have to get a brand new IP address and a brand new address. So it's very important that we use this mechanism. Now, the reason you can't connect to that stateful service from outside the cluster directly when you're in an environment like Azure is because the Azure load balancer itself only knows about IP addresses and ports. It has no idea that there are services running on these VMs. It doesn't even know that Service Fabric is running on these VMs. And it certainly doesn't know about the service discovery mechanism. So when you make a request, even if you did know the port up front and the path up front and everything, if you made a request to that address, the load balancer wouldn't know where to send it, and it would do what it always does, and it would just send it to one of the VMs that it picks based on its load balancing rules. But only one of those is actually hosting the endpoint that we want. And so usually you're going to get a failure when you try to do that. Now, if the client tries to contact the naming service and do discovery outside of the cluster, it can do that. Those APIs are exposed, but what you're going to get back, you see down here, is you're going to get back an internal IP address. And this is an IP address that's internal to this virtual network. This doesn't exist out on the internet. So if you try to connect to that directly, it's going to go nowhere, and that's just going to fail. So you might be thinking, well, I'll just replace the IP address with that DNS name that I got from the load balancer, which is available publicly. But then you're back at the same problem where now the load balancer doesn't actually know how to route that call because it doesn't have that internal IP address. This generally doesn't work anyways because these ports that are opened up are dynamic and they're usually not exposed to the load balancer anyway. So usually you can't connect to it at all this way. So the answer to all this, and this is the reason we have that front-end web service, is because you need that front-end web service to be the thing that sits behind the load balancer and takes incoming requests. Because the load balancer can send traffic to that because you have a well-known port, usually port 80 or 443, and you have an instance of that running usually on every node or on a subset of nodes that the load balancer can actually find. And the point is that they're all identical, so it doesn't matter which one the load balancer sends traffic to. It should work no matter what. And then inside that stateless service is where you then connect to the naming service, do the resolution, and then forward that traffic along to that backend stateful service. And so this is what we call the gateway pattern, and there are a lot of different gateways that you can use. The one that we're seeing here is where we have the Azure load balancer as a gateway talking to a stateless web service running on the cluster. And then there are a couple others that we have in Azure. So Azure API Management, of course, integrates with Service Fabric, and API Management does understand that Service Fabric is running in the back and does know how to use the naming service for service discovery. And then, of course, you can pull data from IoT Hub or Event Hub. So these are just some examples of service gateways that we have. So once traffic is in the cluster, we have to figure out then how do we actually communicate between the two services. And there are a couple ways we can do this. So the first is by doing this direct client-to-service communication, where the front-end service resolves the address of the back-end service and then talks to it directly. And there are a couple options for that. So the first thing is just the raw APIs for doing address resolution. So this is, the problem with this is that it's only available in the SDKs that we ship and the languages that we ship, so C#, Java. There is an HTTP version of this, but they're very difficult to use correctly because you have to cache addresses as they come in, and then you have to be able to do a re-resolve mechanism. So this one's actually pretty tough to use. We do ship a service remoting, an RPC mechanism that you can use. So this one's fairly simple to set up. The problem with this, though, of course, is it is also only available in the SDKs that we ship. So only C# and Java, and only C# to C# or Java to Java. And this does all the address resolution directly in your service, and then you make an RPC call off to it. And the other option is a DNS service. And this one's actually real nice. It's very simple to use, and you just use a simple DNS name to connect to your other service. And then the other way that you can do this is with request forwarding, and this is where we have this feature called the reverse proxy. And in this case, you just make an HTTP request to this proxy that's already running in the cluster, and the proxy itself does that resolution internally and then just forwards the request along. So the DNS service, the way this one works is very simple. When you create the service, you can specify a DNS name, and then when you write your code, you just say, well, I'm just going to make a HTTP request off to that DNS name, and then let the DNS service figure out where that IP address actually is. And this does use the naming service. As we saw earlier, everything goes through the same pattern of using the naming service to look up an address and then figure out where to go. And then the reverse proxy, which has HTTP forwarding, is fairly similar. Again, you just create an HTTP client, and you talk to this special service proxy URL, make a request to that, and this way, now the reverse proxy is doing the heavy lifting of looking up the service endpoint, and then it forwards a request for you. Okay, so let's go back and see how this stuff works. So the best way that we're going to be able to connect these two services together is using that reverse proxy. And the reason we can't use DNS in this case is because the service here is actually stateful. And so the DNS service doesn't work too well with stateful, particularly because this port here is dynamic, and you don't get that port back through DNS. So we're going to use the reverse proxy. So I'm going to switch to a more complete version of the application. This is what you find out on GitHub today. And in here, basically all we've done really is the data service hasn't changed. We've just filled in the rest of these methods up here. So we added our delete and get methods to work with that reliable dictionary. And then we had to go and fill in this controller here. So now this is on the web front end. This is that JavaScript we saw that makes a call out to this. And so if we go and take the put method, for example, here we can see this is where we actually make those requests. Now, in here, this is where we have to grab the proxy address. And so this is actually an HTTP address that we can just make a request directly to. And it's just filling in some things with the service name. So when you make a request out to this reverse proxy, you give it the service name that you want to connect to, and then some partitioning information, which we'll come back to in a little bit. And then you can just make an HTTP request directly to it. And it's fairly simple to do that. So that's all we really need to do. So let's go and deploy this guy out here. And we'll put in a couple breakpoints like we do. And we'll see if this thing actually works. And we'll go back into this controller here and put in a breakpoint up here too. So here's that put method. So while that's deploying, let's look a little bit more at what's happening here in this backend service. So we had this put method that we implemented earlier. Now we have this get method. And the get method is actually just aggregating all of the items that we placed in the dictionary. So it's just creating an enumerable and enumerating through and aggregating them up and then returning them. Now you can see we have this special version of IAsync enumerable here in the Microsoft Service Fabric data namespace. There is an IAsync enumerable available now in the system collections generic namespace. This was all designed before that was available, so now we have our own in here that will eventually get merged together. And then it's just a matter of enumerating through and then returning the result. Notice that we don't get link support in here because this IAsync enumerable doesn't have link extensions. You can take this IAsync enumerable and convert it to a regular IEnumerable and then do link that way, but then you're taking these asynchronous operations and turning them into synchronous operations, which generally isn't recommended because this reliable dictionary is actually a lot of the time going off to disk to pull data out. The data that's kept in memory is just sort of a cache, so a lot of time it's going to end up going to disk and doing I/O operations anyways. So if you have a small data set, you can get away with it, but for larger data sets, typically you don't want to do that. All right, so here we go. We're launching this guy up into our local cluster again. So we'll switch back to our local one node cluster. And this should be going here soon. There we go. So there's our application type. So this is that application type that I mentioned earlier. This is that registration phase. So what it's doing now is it's provisioning that application type with a version. You can see the status here even says provisioning. Once this is done, it's going to go and create an instance of it to run. And you can even do that through SFX here, through Service Fabric Explorer, just by clicking here. And that's that command that we saw earlier in PowerShell when we say new Service Fabric application. Once it's provisioned, you can just create as many instances of this application as you want. Visual Studio will automatically create one for you to get you started. So here we go. This should be going now. Let's see if it creates or if it rolls it back. Here we go. So it's creating that application now. And you can see once that application gets created, diagnostics events start flowing in through here too in Visual Studio. So these are just being outputted through that service event source file which you saw. So that's just event source, and we see that the service is now started up. So that's our Azure cluster. We can close that down. So here's that application now. Okay. So here's the UI. Visual Studio will go ahead and load that up for us automatically. And so the services start up. We got our backend service and our front-end service. And now we can start adding things to it, and hopefully the debugger will catch it. So let's say I'm going to vote on cats. And here we go, we've hit it. So this is now the front end service, that put method. And if we step through this, you'll see we're grabbing a service name, we're grabbing the proxy address, grabbing a partition key because we are partitioned in the back end. And then when we get down to here to this put method, now we're in the second service. This is the second HTTP endpoint. And you can see that made it here where we go into the reliable collection, do the transaction, save the data, and then we are out and we're good. And so now we got this guy. And so now we can continue to vote on it. And every time we vote on it, we're going to hit that breakpoint because it's adding a new value to there. OK. So fairly simple stuff. Now that we have this application up and running, we have to figure out how we're going to actually scale this thing out. So one of the tricks, one of the really cool things that Service Fabric gives you is a way to scale out a data store on the back end. So what's happening right now on this local cluster is that every request is actually coming into the same primary. We only have one node, but if we launch this with just one partition, the issue is that every request comes into the same VM. So if you have a large number of requests, then you're kind of hammering the same VM constantly. So you want to find a way to spread that volume out. So you want to scale that out across a number of machines. So to demonstrate this, I'm going to switch over to a 5-node cluster here locally. And then we can see what's going on. So let's do that. And I'll stop this guy. Now, while that cluster switch is happening, let me switch back over to these slides, and we're going to talk a little bit about how this scale-out stuff works. So what we saw originally was we created a service with a single partition, and this kind of draws it out for you here. You can see that within just that one partition, it's only node 1 that has the primary. So all of your requests are coming to just one single machine, and so that's obviously going to be a bottleneck. So what partitioning allows you to do is it allows you to split up your data into smaller pieces and then distribute it out over a set of nodes. So all of these pieces of the service is one service. It's just been split up and it's been spread out. So now we got a primary replica for different partitions, color-coded, and now requests can come in 2 different nodes, and that way we've kind of spread that load out. Now what can happen though is as you add more nodes, when you want to scale this out, Service Fabric will automatically redistribute these replicas out to those different nodes. But you get to a point what we call the scale limit. And this basically means I've gotten to a point where I have one replica on every node. So if I go and try to add a new node, it really does me no good because I can't split it up further. So there's a trick to this that we can do. We can always create another instance of that same service. And we can pack more stuff onto the nodes we have. And now if we scale out again, Service Fabric can again redistribute things. So the trick here is kind of a combination of partitioning, but also using multiple service instances to manage your data. So let me show you what that looks like here. So what I've done with this application here, I'm going to switch over. I've extended it. So now I've got an extended version of this simple application. And I've got the same controller here. So the controller still has to partition the data. So it does this partitioning thing. And the way the partitioning works is actually fairly simple. I got a couple of helper methods here. I'm just taking in the input data, and I'm taking the first character of that input data, converting it to its numeric position in the alphabet, and using that as a partition key. And the partition key is put into some partitions. So we have a range of the partitions from a low to high. And I used 0 to 25 because there's 26 letters in the alphabet. And when I go and add a piece of data into this backend service, Service Fabric will find the right partition to put it into inside this key range based on that key that I provided, which is just that first letter and its position in the alphabet. So it's going to go into one of these partitions. And then I can create this with as many partitions as I want. So that gets me to that first stage where I've partitioned the data out. Now the cool thing to note is that to do partitioning, I didn't have to make any changes to this backend service. I haven't touched this at all. None of the code changes in the backend service. It stays identical. It doesn't actually even necessarily know that it's partitioned. Because what happens is every partition that gets created, you get a new instance of this class here. So every partition is effectively a copy of the service, but it's getting different data routed to it. So I don't have to write any special code on the backend to manage that. It's only on the front end piece here, that piece that's talking to that backend service, this is the piece that has to know that that backend one is partitioned. So there's a little bit of coupling that goes on here where the front end service has to know a little bit of details about the backend service. I have to know how it's partitioned, and I have to know how to resolve a partition key. So within an application, you can think about it as within an application, it might be okay for services to be a little coupled together and they know how they work, but on a separate application outside of that, that separate application would never talk to the back-end service of this application directly because you don't want to know the intimate details of how it's partitioned. So that part only happens here. Okay, so let's see if that 5-node cluster is still spinning up. So while that's spinning up, let me show you what I've done with this application. So what I've done is I've made a couple changes. And what I'm going to do is, instead of having a single poll represented by the entire application, I'm actually going to create a whole new back-end service to manage every poll that comes in. So whenever a new poll is created, we're actually going to spin up an entirely new stateful service to manage that poll. So this is another way to do scale out. So each poll has a completely separate service that can also be partitioned differently. And the benefits of this is if you have a poll, for example, if you know this poll is going to be really large, it's going to have a lot of data or a lot of traffic, you can create it with a larger number of partitions up front so that it can scale out further. If you have a smaller poll, you can create it with fewer partitions so that it doesn't have to scale out quite as far. But the benefit that this gives you is that as you grow, as the application grows over time, there's really no limit to how far it can grow because you can always continue to create more service instances as the application grows. With partitions, you can't. Partitions can never be repartitioned. So this gives you a way to kind of get around that limitation. So let me show you how this works. So we've done a couple things here. So the first thing is in the votes controller itself, I'm now taking in a name for a poll as well as the thing that's being voted on. And what I'm doing here is when I get the voting data service name, I'm doing something slightly different. So if we go and look into here, I'm going to have this kind of format. So this is the name of the service that I'm going to look for, and I'm going to basically come back with this URL, which is the service name. It says, under this application, I have a list of polls, and then for each one, it has a specific name. So then that's pretty much the only change. So now when we create the service proxy URL, we're just targeting that particular service instead of that default one that we had earlier. And then on the front end, of course, we had to make a couple of changes. And that's just as simple as making sure that when we call into the front end, we're passing in that poll name as part of the request so that we know which service to go to. And in the home page also, you can see here, we're just doing this. We're kind of saying, oh, here's the poll we're looking at currently. But other than that, there haven't been any changes here. Now, in the home controller, we got something interesting too. So when you come into the index page, what we're going to do is we're going to require it to pass in a poll name. So this will be part of the URL. And what we're doing here is we're actually creating these services dynamically. So this is using the Service Fabric APIs. And this is a very unique thing to Service Fabric, is I can create instances of a service on the fly programmatically like this. So since I already have this type registered, which we saw earlier, I can create instances of it at any time I want and as many as I want. So all I have to do is just go through here, fill these things out, and then ask Service Fabric to create that service instance. And then since we don't actually need a copy of this data service, let's go back up to the application manifest. And here's an interesting thing. So down here we see these default services. And default services, what this means is whenever the application spins up, create these services by default. So automatically spin these services up. Now we don't actually have to do that. This is really more of a debugging feature for Visual Studio that makes it easy to attach a debugger because the services come up automatically and the Visual Studio can just attach the debugger right away. But we don't actually have to do this. And most of the time when you're running in a production environment, you're probably not doing this anyways because you want to write the command that actually spins up that service in a CI/CD environment or in a build environment. So we can actually just delete this out of here. And now that service won't come up at all. And so what we can do in the back end too, as you're spinning up these applications, you can actually create these through a script by saying new service fabric service. And here you plug in all the details about how you want to create that service. And this is kind of the normal way of spinning up services when in an application after you've launched that application. And so this is generally what you do in a deployment environment. So if we go back, let's see if our cluster is up here. So we got our 5-node cluster. So now we'll go and deploy this application. So this is our extended one. So we'll go and deploy that out to the cluster. And so when it comes up, we should see that we only have this front-end stateless service, and we don't have that back-end stateless service because we've removed that from default services. And again, the reason is because we're going to go and create those on the fly as requests come in for a new poll to go and vote on. Now it may be a little strange to do this in the home controller, admittedly. You probably wouldn't do this here. Ideally, you'd have a separate API controller where you'd go and you'd say, I want to create my services here. You'd also have some code to then delete the services when the pull is complete. This is just kind of a shortcut for demonstration purposes, but usually you take this out somewhere else. You can even do something like this query here, which checks to see, does the service exist? And if it doesn't, you can issue back a 404 response, for example. So that's all that code here does, and then we take that service name and we just display that out in the UI. All right, so while this is deploying, let's talk about some of the limitations of this approach. So if you're doing this approach with dynamic service creation, you can get pretty far. There's no hard limit on the number of services that you can create. But there are practical limits, obviously, based on how large your cluster is and how much hardware you have backing that cluster. So there is a small amount of overhead when you are creating a service that you have to think about. But if you're up in the thousands or tens of thousands of services range, you should be fine. Once you get up into the hundreds of thousands and millions of services, that's when you're going to start to need a much larger cluster to handle that, because each one of those does have a small amount of overhead associated with it. Now, the amount of overhead, too, can be controlled slightly by this activation mode. So this is that host process activation that we talked about earlier, where that program entry, the program main entry point, is the host process that can instantiate services in it. You can actually decide if you want to host multiple service instances in the same host application, in the host process, by changing this off to shared process. And this is actually the default if you don't specify anything. And what that means is when we spin up this service here, we can actually pack multiple instantiations of this service class into the same host process. So this can give you very high density, but at the cost of a little bit of complexity, because now you have services represented by .NET objects sharing the same process. So they're sharing the same memory space, and it becomes a little bit more difficult to keep track of the amount of resources that the service is using. So the amount of CPU and memory that's being used becomes a little bit harder to keep track. So we generally recommend that you use this exclusive process mode, and that means every time you create a new service instance, it will get its own host process, and that makes it a little bit easier to keep track of the resources that it's using. And also, if one of those service instances were to crash, if you were to get an unhandled exception, for example, you don't necessarily want it to bring down the entire host process for multiple services. You only want that one service to come down. So that exclusive mode becomes much easier to work with and much easier to debug, but at the cost of now you're just spinning up multiple processes. All right, so the application is now deployed. So let's take a look at what's in here. We can see that we only have one service now. This is just that front-end service. And we don't have any instances of that stateful back-end service, because those we're going to go and create on the fly. So if I go, so now when I go to the home page here, you can see there's nothing. It's actually a 404 that Firefox is hiding for me. But if I go in and I go to this address that we set up, let's say I create a test poll here. Now watch what happens here. So back in SFX, in Service Fabric Explorer, you can see now it's automatically instantiated a whole new service just for this one poll. So we can do that again a couple times. And we can say, now I want a second poll, call it poll 2. And again, Service Fabric is now instantiating a whole new service just for that one poll. And each one of these services has its own set of partitions. And I've got it set up just for one partition, but you can, of course, parameterize that so that every time you create a new service instance, you can set the number of partitions that come in. So let me refresh this and make sure we have the latest code running here. So now if I go and add in a new poll here, it should come up. Oh, this guy's got a problem. That's all right. So each one of these basically will manage its own poll, and now we can create as many as we want, and each one will get its own service instance, and each one can scale out independently. So these errors will go away after a little while. This is just kind of a startup thing. It's a little bit slow to get started. But using this technique, you can scale out very, very high, and you don't have to worry about trying to get the right number of partitions set up front, because every time you create a new poll, you're going to get a whole new service with its own set of partitions. And this way you can kind of keep going and keep expanding, so you can plan a little bit further ahead than you would with just one service. And it also gives you some additional management capabilities, because you can actually use the Service Fabric commands to manage some of these services. So if I wanted to delete one of these, say for example this misbehaving one, if I want to just delete that poll entirely, I can just click delete service and it's gone. And it'll be just that easy. So I'm actually making use of the Service Fabric APIs to do a lot of the work for me, so I don't have to write all my own APIs for creating and managing and deleting. Okay, so now when we add cats, we should get We can now vote on that. And we have a separate poll here. And we can add dogs. And now we can vote on dogs in this separate poll. So now we have 2 separate polls managing all this data. So that way we can scale out. All right, so that's pretty much it. Let's go back here and we'll give you a couple resources at the end. So if you want to see more about Service Fabric, we have this address aka.ms/servicefabric. This will take you right to our documentation. The sample that we showed is available up on GitHub. You can go and download that and play around with it a little bit. And make sure to check out some of the other videos that we have up on Channel 9 and, of course, MVA. All right, thanks so much for watching, and have a good day.